All right, let's talk about water solubility. All right, so let's say if I have a spoonful of sodium chloride drop into water, what happened to it? Just disappear? No, it dissolved in water. Right now, if I have an iron 3 oxide, which is rust, okay, rust look like that, drop into water, what happened to it? Disappear too? No, it stay. Right? So it's not dissolved. Now we got sodium chloride, a solid like sodium chloride that dissolve in water, and we have a solid like rust, which is insoluble in water. How do we know though? Right? Which solid is soluble or insoluble in water? All right, so start with the sodium chloride. Well, we know this is soluble in water. All right, so sodium chloride is an ionic compound, and an ionic compound exists in nature as what? A molecule? No. Exists in start with L. Lattice. Okay, an array of ions. All right, and this lattice is pretty stable because each ion is stabilized by the opposite charge ion nearby. So I mean, it's pretty happy. Everyone's happy. All right. Now, when we drop sodium chloride in water, so lattice. So sodium chloride got two options. Either one, stay as a water insoluble, stay as a solid, or let water stabilize the ions. Okay. And so right here, so they break apart and the water comes around it, right, and then stabilize the ions. Now, how do we know if sodium chloride is going to stay as a water insoluble or let the water stabilize them? Well, we have to compare the stability. Which one stabilize the ions better, right? If let's say if the stabilization by ion is more stable, sodium chloride in water will stay as a lattice. But if water do a better job, stabilize all these ions better, so they are happier with water. So they'll let water do the work, so break down and become water insoluble compound. Right? So it's like give you an analogy. Let's say you graduate, you have two job offers. Now, which company? Company 1, company 2. Which one you're gonna go? Depends on what you have to look at. Well, it depends many factors. Salary depends on the location. Depends on your interaction with colleagues, right? Your boss. I mean, the nature of the job. I mean, there's just a lot of things. But ultimately, which company that you go to depends on which one you feel more comfortable with them, right? Which one you feel comfortable living financially or whatever. Same thing here. Which interaction, the ion interaction or water and ion interaction, which interaction stabilize the ions better? Ions feel more comfortable or more stable, they will go to that one, right? So, all right, now, just to summarize, so sodium chloride in water have two options. One, to let water stabilize it. If the stabilization with water makes ion more stable, so look at the potential energy here. This is a chart, right? This is the graph. If the stabilization of water make ions more stable, sodium chloride will become water soluble. However, if a solid more stable in a lattice, right? So ion interaction is more stable, they will stay as a solid and become insoluble, right? Water insoluble compound. Okay. Now the question is, how do you know which interaction, the interaction with water or ion interaction, which interaction stabilize the ions better? Well, there are a few factors. Here we go. Charge of ions, size of ion, how well ions pack. Start with the first one, charge of ions. Okay. So I'll give you two examples. First one, we have sodium chloride, and you know the charge sodium +1, chloride -1. And you know sodium chloride is soluble in water. So the usually low charge, they don't attract one another strongly. So they tend to be soluble in water. On the other hand, rust, iron 3 oxide, so iron +3, oxide -2, they bind more strongly. Because the higher charge, they bind more strongly. So they tend to become insoluble in water. All right. And now, so I give you some more example here. So we have the soluble compound down here. So lead, barium, and aluminum. But the anion are -1, nitrate -1, chloride -1, perchlorate -1. But sulfide, carbonate -2, phosphate -3. Right? So usually compounds with charge of 2 or 3 tends to be insoluble in water. These top 3 are insoluble in water. That's a charge, right? But again, charge sometimes it's really hard to predict. I'll give you some example. Halogen is really troublesome. Chloride, bromide, iodide, they all have negative charge, 1, right? -1 charge. So it's supposed to be soluble in water. And they are, like with sodium, with magnesium, with potassium, they're soluble in water well. However, there's an exception. Silver, copper, mercury, and lead. When these 4 pair up with any of this, they become insoluble in water. No idea what's going on there, right? The size of ions and how well ions pack come into play, and this one really difficult to determine. We don't know, right? Silver and chloride love each other so much, and they never separate. They're not soluble in water, and I don't know why, right? It's really difficult to predict. Fluoride, the smallest in group 7, -1, supposed to be soluble with everything, but no, precipitate with most metal. It's so difficult to predict. So how do we know if the compound, if an ionic compound is soluble in water or not? Well, it's gonna be the experiment. You have to like take this like the solid down into water, take the solid down into water, and do the experiment. That's all you have to do. And there are tons of ionic compounds, millions of ionic compounds in this world. Well, the people do it and come up with this. We can talk about this on the next video.